are saying that table can be obtained either by experiment or existing equation. The first shot was a table gotten from a real-life experiment, and in our case, it was conducted on a vehicle. The rate of consumption of fuel by a vehicle. With that table, and by hypothesis, we got a formula that predicted the character of that vehicle with respect to fuel consumption. What if we have to get our table from an existing mathematical equation? How do we go about it? That takes us to lesson number 9, and that is how to make table from equations. Please join me as I explain step by step how to create tables from an existing mathematical equation. Please follow me as I do it. What you see on the screen is an example of how to make table from equation. How to make table from equation. Don't forget that before we plot graph, we should have a table. Let this serve as one of the examples of tables we can get from an existing equation. And later, we'll talk about a table we get from experiment. Now, let's see an example of how to make a table from equation. We are given this equation, y is equal to 6x minus 1. And x is such that minus 3 is less than or equal to x, and x is less than or equal to 2. This is a statement of inequality, giving us the range of the values of x. When interpreted, look at what it means. It means from minus 3 to 2. Start counting from minus 3 to 2. Any values you get, make range of values for x. So the first thing we have to do before we get a table for this equation is to get range of values of this independent variable. X must have range of values. And from that range of values, we also get range of values for y. Therefore, with this inequality interpreted, we have these values. X is equal to minus 3, minus 2, minus 1, 0, 1, 2. Now, what is next? To make a table, we start making substitutions for x. Since x is not one value, there are up to 6 different values of x. 1, 2, 3, 4, 5, 6 different values of x. 6x minus 1 is equal to y. As x keeps changing its value, y would also be changing its value or putting on new values. We're going to start to get the value of y by making a substitution for x with minus 3. After it, we do such with minus 2. After it, we do the same thing with minus 1 down to 2. Let us start with the first substitution with minus 3. Please watch. When x is equal to minus 3, what is y? Y is obtained simply by substituting this x with minus 3. See the 6 here. It is still there. X is now minus 3. Why this bracket? It is to help us remember that 6x is a multiplication. If I simply write 6 minus 3 without a bracket, it turns to subtracting 3 from 6, which is equal to 3. But with this bracket, we know that what we are doing here is multiplying 6 by minus 3, or multiplying minus 3 by 6. But there was no bracket here before. That is because it is understandable that 6 and x are not of the same sort. 1 is a constant, that is 6, while x is a variable. There is no need to introduce a bracket to separate a variable from a constant if the two of them multiply each other. But if a constant multiplies a constant, like this one multiplies this, to make it different from other operations, we have to have this bracket. I now hope you know why the bracket is necessary. Now let's make progress. Y is equal to 6. This is 6. Then this x is this minus 3. Minus 1 is still there. Now carry out this operation and tell the answer. 6 times minus 3 is minus 18. Minus 1 had been there before. So what you have here has now become what you have at this point. Therefore, y is equal to minus 18 minus 1. What's the answer? Y is equal to minus 19. I hope you know how this became minus 19. If you don't know, go back to the principles of mathematical operations, which I taught earlier. Therefore, you know why this became this. Next, when x is equal to minus 2, that is, no longer is x equal to minus 3. It is now equal to minus 2 because we are through with this minus 3. We're now going to go to this minus 2. See it here. When x is minus 2, just replace this x here with minus 2. That is what I have done here. So 6 times minus 2, then the answer from it, we subtract 1. That gives rise to, please, 6 times minus 2 is minus 12. Then this minus 1 is still there. So y is equal to minus 12 minus 1. What's the answer? Y is equal to minus 13. The same reason applies here. Next, when x is equal to minus 1, why? We are through with minus 3. We're also through with minus 2. Now, we're going to minus 1. That is why I say when x is equal to minus 1. What is next? Replace this x here with minus 1. And what do we have? Y is equal to 6 bracket minus 1, then minus 1. It is this equation we are treating. Y is still where it is. 6 is still where it is. Only one thing has changed. What is it? This x has become minus 1. That is why it is here. Then this minus 1 is still where it is. Please simplify this operation. 6 times minus 1 is minus 6. Then minus 1. See it here. Therefore, the answer is equal that y is equal to minus 7. We are now through with this minus 1. Next is 0. That's why the next one says when x is equal to 0. What happens next? Just replace this x with 0 so that 6 remains the same place where it is. But now x has become 0. Then minus 1. See it here. So 6 times 0 is 0. Then 0 minus 1. We have it here, 0 minus 1. The answer is that y is equal to minus 1. The same reason accounts for this answer. Let us now go to the penultimate one. That is the one here. Now replace this x by 1, and let's see what the answer turns out to be. When x is equal to 1, y is equal to 6 bracket 1 minus 1. 6 times 1 is 6. Then minus 1. 6 minus 1 gives us that y is equal to 5. Then the last one is this 2. Replace this x with 2. That is what is playing out here. That is what is playing out at this point. So let's consider it. When x is equal to 2, y is equal to 6 bracket this 2 minus 1. Therefore, carry out this operation and simplify it. 6 times 2 is 12 minus 1. So y is equal to 12 minus 1. 12 from these 2 minus 1 had been there before. So 12 minus 1 gives us that y is equal to 11. I hope you followed what happened here. At this point, we summarize this exercise with a table. Look at this table. This table can stand vertically downwards, or can sit the way it is doing right now. But in any case, we have to write the equation with which we obtained this table here. This table is a summary of what happened here. In fact, sometimes we don't have to go through this long exercise before drawing a table. As beginners, this is suggested, but as we get more and more experienced in this art of making tables from equations, we can become very fast in doing so by passing this process. In the course of time, you will see its possibility. Again, look at this table, summarizing this exercise here. When x was equal to -3, y was -19. See it here. X is -3, y is -19. So this is summary of this first line. This is summary of second line. This is summary of third line, and so on and so forth. Meaning, when x was equal to -2, see it here, y became -13. See it here. When x became -1, see it, y became -7. See it here. When x became 0, see the 0, y became -1. See the -1 corresponding to it. When x was 1, that is 1 here, y we got as 5. See the 5 corresponding to it here. And finally, when x was 2, we got y as 11. See it here, 2 against 11. This is one example of how to get a table from equation. Later, we plot the graph of this equation. And now, checkpoint A, see it on the screen. Given a corresponding range of values of x, make tables for the following linear equations. The first, that's number 1, y is equal to 4x plus 1 for this range of values of x. That is, -2 is less than or equal to x, and x is less than or equal to 3. Number 2, y is equal to 3x minus 7 for this range of values of x. Number 3, y is equal to x plus 3 for this range of values of x. Please try and compare your results with results of others. If you discover you have made a mistake, go back and correct your mistakes. It is worthwhile.